Fahim is waiting at the village railway crossing. In the distance, a massive express train is rapidly approaching. As the train speeds toward him, the driver pulls the horn. It blares with a sharp, high-pitched scream. But the exact second the train passes him, the sound violently drops into a low, deep, groaning pitch. Fahim is confused. Did the driver suddenly change the horn from a high note to a low note as he drove by? The next day, Fahim asks his physics teacher. Mr. Sir smiles and says, "The horn never changed. Your ears were just tricked by physics." To understand why, we first need to remember what sound actually is. Sound is simply invisible waves of pressure traveling through the air. Imagine a frog sitting perfectly still in a pond, tapping the water. It creates perfectly round ripples that spread out evenly in all directions. If the waves are close together, they hit your ear rapidly. We call this a high frequency, which your brain hears as a high-pitched sound. If a train is parked at the station blowing its horn, the sound waves spread evenly. Everyone hears the exact same pitch. But what happens when the object making the sound starts moving at high speed? Think of our frog again. If he swims forward while tapping, he catches up to his own ripples. The waves in front of him get squished together. Because the source is chasing its own sound, the waves in the front are physically compressed into a much tighter space. This is exactly what happens with the train. As it speeds toward you, it shoves the sound waves together like a compressed accordion. When those tightly packed waves hit your ear, they strike very fast. This high frequency creates that screaming, high-pitched horn sound. But then, the train passes you. The situation instantly flips completely upside down. Because the train is now speeding away from the sound it just made, the waves behind it get stretched out incredibly far apart. These stretched out waves hit your ear much slower. This low frequency makes the horn sound deep, lazy, and low-pitched. This squishing and stretching of waves due to motion is a famous law of physics called the Doppler Effect, named after Christian Doppler. The craziest part? The pitch never actually changes. If you are the driver sitting inside the train, moving with the horn, the pitch stays exactly the same. The singing train is an illusion created entirely by your position relative to a moving object. And it's not just trains. This is the exact same physics that makes a speeding race car go vroom as it passes the grandstands. But the Doppler effect doesn't just apply to sound. Light is also a wave, which means light can be squished and stretched too. When astronomers look at distant galaxies, the light waves are stretched out because they are speeding away from us. This makes them look redder, proving the universe is expanding. We even use this trick to bounce radio waves off clouds, which lets meteorologists measure the exact speed of incoming storms using Doppler Radar. Armed with this new knowledge, Fahim stands at the railway crossing a few days later. As the express train screams past him, dropping its pitch, he doesn't hear a magic horn. He just hears the beautiful, invisible laws of physics singing to him.